Hey guys, it's Andre from High Performance Academy. Welcome along to another one of our webinars. Today we're going to be talking about a topic that I think a lot of people probably don't appreciate just how important it is, and that's the issue of restrictions in the intake system of your car. I know that everyone realizes the importance of potentially upgrading your air filter. I see all manner of people fitting aftermarket pod filters into their engine bays, but it's not without a full understanding of actually what's going on there. And sometimes, as we'll find out as we get into today's webinar, going from a stock airbox to an aftermarket pod filter may actually end up reducing your performance, because now that pod filter is sucking in hot air from the engine bay, which is much less dense. So in our webinar, we're going to be addressing some of the restrictions you'll find in your intake system. We'll go over how you can actually test and find out if there is a restriction in the first place, and then also how you can narrow down the specific areas that you need to focus on, allowing you to get the best bang for your buck, while hopefully also being able to keep a fresh cold charge air going straight into your air filter. Before we get into that though, just wanted to cover what's been going on over the last week, and really excited to start with to announce that we have finally released our long-awaited practical diesel tuning course. This is something that we actually hoped to release late last year. A whole bunch of things conspired against us and it just didn't quite happen, but we're really excited that this week we managed to get that live. So for those who have been interested in the diesel tuning world for a while, you'll know that we do have our diesel tuning fundamentals course already available. That has been out for a fair while, particularly I think for any budding diesel tuners, particularly if they've come from the gasoline tuning world. It is a really big step, and there's a lot of things change when we go into the diesel tuning world. A lot of the concepts that we may have learned from the gasoline tuning world are basically turned on their heads when we start tuning diesel engines. It's also been really difficult to find solid information about diesel tuning and about the process of making modifications to tuning your diesel engine. So our diesel tuning fundamentals course has been out, as I say, for a while, covering, as its name implies, the fundamentals behind diesel tuning, but we wanted to back that up with our practical tuning course, and we have just done that. So what we've done with this course is we have partnered with Nick Pregnetz from Duramax Tuner in the US. Nick actually came over and filmed the course here at HPA Labs in Queenstown. And the reason we have partnered with Nick is that he just simply has a huge amount of knowledge out there in the diesel tuning industry, and particularly a lot of the trucks that we are getting requests for tuning on are American diesel trucks. So we're talking here about the likes of the Duramax, the Power Stroke and the Cummins diesel engines, and Nick has got a lot of experience on all of those platforms. So what we've done here is we've broken the tuning process down into our usual HPA step-by-step process as well, to make it really easy to understand. So what I want to do is just show you that course briefly. So we'll head across to my laptop screen. I'm logged in at the moment. What we're going to do is just show you how to find that course. So we'll head over to our courses page there. I managed to open it as a new tab. That's always good. And if you scroll down, you'll find our diesel tuning fundamentals course down here. For those who aren't aware that we've got that course, feel free to have a look at that at your leisure as well. We scroll down to the bottom, we have got our practical diesel tuning course. So we'll just click on that course and find out a little bit more about it here. So this is the truck that we actually purchased here locally, our Chevy Silverado, for doing some of the course development, and again Nick used that for part of the course. What we've found, actually, just to give you some insight into the amount of power available, that Chevy Duramax in our, or L5P Duramax in our 2018 Silverado in stock form produces 450 horsepower at the wheels on our mainline Pro Hub dyno with no hardware changes at all. Nick took that up to 550 plus wheel horsepower, massive increase in torque as well. So just scroll down here, I'll go across to the course and show you what is included. So we start here with our diesel tuning basics. So this is some of the core concepts that you'll need to understand, including in particular how the diesel engine works. Very different because it is a compression ignition engine, obviously no spark plugs in a diesel engine, and some of the tuning considerations as well, particularly in the diesel tuning world, a lot of the vehicles, particularly trucks, are being used to tow very heavy loads. We need to keep that in mind, because a tune that would be perfectly safe when the truck is unladen, if you now go and put a huge load on the back of that truck and tow that load up a long incline, all of a sudden your perfectly safe tune could actually end up being very dangerous to the engine. So it's important to understand considerations like this. We look at some of the options when it comes to diesel tuning, and this has been a little bit tricky as well. There's a lot of piggyback modules out there, and there always have been for diesel tuning. A lot of these are pretty basic, and they essentially just fool the factory ECU into increasing the fuel pressure, and that will simply increase the amount of fuel being delivered for a given pulse width. Now that works to a point, but it's a pretty crude method and it doesn't give you a lot of control. Particularly this can be a way of increasing power, but also resulting in a lot of exhaust smoke. We've also got a handful of standalone ECUs. One of the ones we will be adding to this course is the Motec M1 GPR diesel package. I've got one of those that we've been in-house testing for a couple of years now. Far and away, the most common way of making changes, though, is with reflashing, and a lot of the course will focus on reflashing. We also discuss, and I think this is misunderstood by a lot of even professional diesel tuners out there, some of the sensors that you are going to need if you want to tune diesel engines. A lot of tuners will rely solely on input from an exhaust gas temperature sensor, which is great to a point, but particularly if you're running a late model engine with a DPF for diesel particulate filter in the exhaust, that EGT sensor alone isn't going to tell you all of the information you need. It's very easy to end up creating a tune that will very quickly clog up your DPF. So in particular there, we talk about adding an air-fuel ratio sensor, and what sort of target air-fuel ratio or lambda you should be aiming for if you want to maintain a relatively safe and smoke-free tune. And we move into some of the more advanced tuning concepts as well. So here we talk about aspects such as fuel quantity. This is really one of the keys to diesel tuning. Fuel pressure and injection timing. We look at the impact on fueling on diesel tuning. Timing calculators. We talk about fuel delivery and the diesel particulate filter in this case as well, because here at HPA Labs we are lucky enough to have a smoke meter or opacity meter. We should do a demonstration with Nick on our Silverado where we have the opacity meter fitted into the exhaust pre-DPF. The problem with the DPF is that, of course, if it's doing its job, the exhaust output from the exhaust tip is going to be nice and clean and smoke free, but we don't know what's actually going into the DPF. If we add too much fuel, we're going to be creating a lot of smoke pre-DPF, and that's going to quickly clog the DPF. So we look at exactly how that works, and you can get feedback using the opacity meter. We look at how to make boost control changes as well, and how that is important. In particular, the turbocharger is our friend when it comes to common rail diesel engines. What we really have is a fairly narrow range of air-fuel ratios over which we can safely tune. So in order to make more power, what we want to do is add more fuel, but also add more air in order to still maintain a safe air-fuel ratio. So you'll learn all about that. You'll also learn about torque management and tuning for fuel economy. Then we move into the HPA 5-step process. So again, this is a step-by-step process that can be applied to reflashing any diesel vehicle. We look at downloading the stock ROM file, how to prepare the vehicle for tuning, configuring our base tune file, optimizing that tune on the dyno, and then confirming everything works perfectly out on the road. At the moment, we've got one example in our worked example library, and this is on EFI Live. That's the tuning platform. This is on a 2005 LLY Chevy Duramax engine, and Nick will be adding to that library of worked examples over time. So just like our other practical tuning courses, our practical standalone and practical reflash tuning course, we're going to be getting as much content into this and covering as many different vehicles as possible. So if you are interested in purchasing that course, the course itself is $229 US. You can still use our payment plan, and I think off the top of my head that brings it down to something like $26 US a week. Can't quite do my math at the moment, but somewhere in that region anyway. So if you are interested, you can find that at the bottom of our courses page at hpacademy.com/courses. It is a great course that will also give you 3 months access to our private members only webinar, and Nick has graciously agreed to provide tutoring on the diesel subforums as well, so he'll be in there answering all of your diesel tuning questions. And before we get asked, I know there's probably a few of you out there asking, are we going to be adding any content on European diesel engines? And the answer is that yes, we do want to do that. It is 100% firmly on our radar, and we're going to be seeing what we can do to add those courses in, or those worked examples in, as time goes by. Right now, I cannot give you an answer to when that is going to be. Just understand though that the principles behind diesel tuning are not going to change. They remain the same. So basically, even if you are looking at tuning a late model European diesel engine in a passenger car, everything that you'll learn from that course is still 100% applicable. Nothing changes there. All right, I wanted to give you a long overdue update on our FD3S project car as well, and I'm actually going to sort of approach this fresh because unless you've been following us for a fair while, I haven't actually been talking about this car for quite some time. So I'll jump across to my laptop screen, and here's a couple of shots of the car. I actually haven't got anything from the outside, but it's probably the engine bay that's the more interesting part anyway. So we didn't inherit it, we bought this car off Zach, who was our wiring tutor, who left us a year or so ago now, and this was purchased because it was just such a tidy car. Zach was pretty fastidious, and he had gone basically through a full exterior refinishing of it, so the whole car had been resprayed and it's absolutely immaculate. Also had, while it was a stock engine, it had an engine in it that was in good condition. It can be a little bit tricky to find with rotary engines. Unfortunately, a lot of them haven't been treated that well, haven't been tuned properly, and most people who have got any idea about rotary engines do understand that they are quite fragile, hence they're pretty easy to damage. So at the moment, the 13B engine in this is stock. I don't know if I mentioned, this is an FD3S RX7 Series 7, and what we wanted to do was basically update the turbo system and make the most out of this factory engine. So what we've got is a Turblown turbo kit. Elliot from Turblown's been gracious enough to help us out with this kit, and it includes a Borg Warner EFR 8474. Now unfortunately, we have really been dragging our heels with this project. At the time that we got this turbo kit, this was the first 8474 inside of New Zealand. Would have been great if we'd been able to get content on it back then when we got it. Unfortunately, we had too many other projects on the go, and this has dragged on for a little bit. That turbo sits on a investment cast stainless steel exhaust manifold that Turblown produce, and we ended up getting a local fabricator up in Christchurch, Vinny Fab, to finish off the fabrication work. We can see there's a V-mount intercooler setup. He's also built a custom radiator, and there's obviously the intake pipe here that's been made. Fitting with today's webinar on intake restrictions, you'll note that the intake pipe actually runs right in front of the radiator and intercooler, so it's actually going to be sucking nice fresh cold air from the front of the vehicle. This is another shot of the turbo installation, and we can see that at the moment there's Inconel heat shields over all of the turbo manifold and the exhaust housing. Rotary's renowned for producing a lot of heat, so that's quite important. The exhaust manifold itself is fitted with twin Turbo Smart external wastegates, so we've got one external wastegate per exhaust runner. Really important as well, the way the wastegates are integrated with that exhaust manifold means that it's nice and smooth, really easy for the exhaust gas to get out through those wastegates, which means that we're going to get nice stable boost control. There's a couple of things I just want to show you here, a little bit hard to see probably given my crappy photo, but there are a couple of sensors that are located here on this rear exhaust runner towards the engine itself. So this one here, this is a EGT sensor boss, so we're going to be running two exhaust gas temperature sensors into the exhaust runners, just to allow us to monitor those exhaust gas temperatures. We don't have individual rotor lambda, so that's going to be helpful to some degree with individual rotor fuel tuning. And then this particular boss here, this is for an exhaust back pressure sensor. So a little bit hard again to see here. We've got a couple of exhaust back pressure sensors over here, and these are fitted on top of a damper canister, so we're going to get a nice smooth output from the two exhaust gas pressure sensors, or the two tappings into the exhaust manifold there. So all of that data is going to be fed through into our ECU. On the fuel side as well as the ignition side, what we've done here is we've gone away from the stock system which runs 3 coils, or a waste spark coil. We've gone to a set of 4 of the popular IGM-1A coils there mounted. They're going to be on top of the engine block there, basically sitting nicely underneath the intake manifold, so that should give us plenty of spark energy. While you can see it in the photo here as well, we have got a Continental ethanol content sensor fitted here on the firewall as well, so we're going to be running a full flex fuel system on this. One of the problems with rotary engines is that they are incredibly thirsty, so the stock injectors were never going to cut it. And here we've got a new secondary rail here, which we can see mounted down on top of the block. We are running injector dynamics injectors primary and secondary. We've got a set of 1300 and 1700. The fuel rail components and the conversion kit there are from CJ Motorsports, and that's the primary rail here. So this, interestingly, I'll just get this under our overhead camera as well. It's just an aspect of the fuel rail there that I just wanted to show you. I'll get that under there. So first of all, there is a conversion collar that comes with this kit from CJ Motorsports, which makes it nice and easy to fit the popular injector dynamic style EV14 style injectors in place of the factory injectors. And on the underside of the fuel rail, I'll just make it a little bit more obvious, there is also a fuel pressure damper. And this is something that a lot of people kind of completely ignore. The fuel pressure damper is quite a common installation on most factory fuel systems, and quite often when building aftermarket fuel systems, the fuel pressure damper is taken out, thrown away, and completely forgotten. And while in a lot of instances you might not notice the difference, in some cases, and we've seen this particularly with our Nissan 350Z, which runs 2 dampers, one of them on our particular car did fail, and we saw some really weird problems with bank-to-bank lambda variations at particular RPM ranges, where it must have been a harmonic or resonance that was causing fuel pressure fluctuations. So if you can incorporate a damper, it's definitely an advisable aspect to consider. Moving on, just as well on this note, we are running an Adaptronic modular ECU. So we've been asked for some time to produce some both rotary and Adaptronic content for our practical standalone tuning course, and that's exactly what we're going to be doing there. So at this point, the rest of the wiring is just being completed, and there's a few mechanical jobs that Brandon has been finishing off, including plumbing up the new fuel system and mounting a few of those sensors that we needed mounted up in the engine bay, basically tidying up all of those loose ends. So hopefully we're not too far away from being able to get that engine actually up and running. Now, there are a couple of other aspects that I wanted to mention here, and this is our brand new twin plate clutch that's just arrived from Japan. And given that I owned a workshop for about 13 years where we modified all manner of street cars, one of the common themes I saw was people choosing a clutch that just wasn't suitable for their car and their use. So of course we do need a clutch that's going to be able to support the amount of torque that the engine produces without slipping. I mean, that should go without saying. If we can't support the torque that the engine's producing, obviously we're just going to be smoking the clutch, and that's not going to be a lot of fun for anyone. However, what I saw time and time again was people going with a clutch that was really designed purely for race car use, and these would be twin plate or triple plate clutches, normally a sintered bronze style material, friction material, which is quite harsh, and then usually with an unsprung center. And what this does is it creates a car that, while it might be great out on a racetrack where you're not too worried about the drivability, around town, particularly in stop-start traffic, it can just completely destroy the drivability of the car, and that takes a car that might be a lot of fun out on a racetrack and makes it just absolutely horrible and a complete chore to drive. So if you want to enjoy your project car and it is going to be street driven, it's worth giving a little bit of thought to the clutch type that you are going with. In our own experience, my own personal preference where possible is a carbon or carbon clutch with a sprung center. We've got one of those in our Toyota 86 development car. The particular clutch in that is a carbonetic, and it's just beautiful to drive. The carbon material is really easy to slip, and it's not going to end up getting damaged. It handles the temperature of being slipped quite nicely. So basically that style of clutch gives the drivability of a stock clutch, but it gives a lot more torque handling capability. So that's one end of the spectrum. For our FD3S RX7, we looked at our options and we went with an Ogura racing clutch or ORC clutch from Japan. With the FD3S RX7, we needed to remain pull type, which is the type of actuation. And what we wanted to do obviously was have something that was going to be able to handle the torque we're capable of producing with that 8474 turbo. So I'll just take the cover off here for a moment and we'll get our top plate out of the way. And what we can see here is this does involve a sprung center hub. The Ogura racing clutches as well pretty well renowned for being quite nice and drivable. So despite the fact the material that they are using, obviously we're not running a carbon style clutch here, are still nice and easy to drive. They're not going to shudder. They take up nice and smoothly, and that sprung center just helps with that as well. The way these are constructed is that the clutch discs are splined to a central hub. The central hub then splined to the input shaft of the gearbox. So the other aspect with the sprung center that's important to understand there is not just about making the clutch a little bit more drivable. What that will do is it will take out a little bit of the shock loading that gets transmitted into the drivetrain. One of the problems with the FD3S RX7 is that they are known for the gearbox not being particularly strong, and given that we're potentially going to be making upwards of 450, 500 wheel horsepower, hopefully more than that once we've got a built engine in it, that's going to be a real torture test for that gearbox. I've seen time and time again with engines making plenty of power coupled to gearboxes that are a little bit weak, a solid center clutch is just going to transfer all of that shock loading straight into the drivetrain and can quickly destroy it. So just a few considerations if you are in a position where you're looking at upgrading your clutch for a project car. Don't think that just jumping to a competition twin or triple plate clutch is going to be the best option for you, particularly if you need to keep your car drivable. Now, just before we move on from our RX7, I also just wanted to mention this little work of art that we've got over here. So this is the plumbing for our twin external wastegate. So the Turblown kit that we got for our FD3S RX7, the external wastegates are plumbed to atmosphere. Great for a race application, but that's actually illegal for our purposes if we want to keep the car on the street in New Zealand. And the guys from Vinny actually went above and beyond, and they plumbed the wastegate separately all the way to the rear of the car with its own muffler. Now, we've posted about this before and we've had a few people say, oh, what a waste of time, don't really need to do that. The theory here, and I don't say this has to be done, we've done plenty of exhaust systems where the wastegates are plumbed back into the exhaust, and provided that the rest of the exhaust system is free-flowing enough, that shouldn't necessarily present a problem. However, understandably, both of those wastegates are venting some amount of exhaust gas. If we have to flow that back into the main exhaust, then the main exhaust then has to flow more total exhaust gas, so it can present more of a restriction. Obviously dumping these to atmosphere is just not a consideration, and this can potentially show a small improvement in performance. So that's what we've got there. It's just plumbed all the way to the rear of the car. Understandably, when we are dealing with exhaust components, these components are going to be getting hot, then they're going to be cooling down. So there's a lot of consideration needs to be made here for thermal expansion. And that's what I wanted to actually show you here. Let's get this under our overhead camera. We've got these two little units here which allow the exhaust system to stay completely sealed, yet they do allow the exhaust system to expand and contract. And the important part here is if we didn't have something like that in the exhaust system, then you're going to end up with this beautiful creation cracking over time as it heats up and it cools down. The advantage with these particular units as well is that they are 100% sealed. So I see a lot of people do this with slip joints. Not necessarily a bad option, and they can work, but the slip joints almost always are going to leak to some degree. So just a really nice solution to getting the ability for that exhaust system to expand and contract as it's operating. All right, we're going to move on, and if I can just get back across to my YouTube channel here, we'll come across to my laptop screen, and our Tuesday release video has just gone live a couple of hours ago, and this is a car that we shot just as they were starting to pack down at SEMA 2019. Absolute work of art here, and it's quite unique. This is an E36 BMW built by World, and the interesting part here is that it produces 1150 horsepower and only weighs 1100 kgs. It's actually built to compete at Pikes Peak, where it should be competing this year. The engine in that car is essentially a BMW GT3 M6 engine. However, it's been vastly modified compared to the trim that it runs in the GT3 series. Obviously necessary in order to produce 1150 horsepower, in particular with a larger set of turbos and beefed up internals. The aero package on this car is pretty impressive as well. The front splitter has been designed to produce somewhere in the region of about 2,000 pounds of downforce, just to match the amount of downforce being produced by that rear wing, as well as the underbody tunnels in this car. So the whole thing, in order to basically make this car work, the whole car has also been tube framed. So if you want to learn a little bit more about that car, head over to our YouTube channel. While you're there, please make sure you subscribe. If you like that video, give us a thumbs up, and if you've got any questions, please feel free to ask, and I'll try and answer them in there. Lastly, for today, we are running another one of our giveaways, and this time we have partnered up with the team from Marley Motorsports in the US to provide a set of their shelf stock forged pistons. So basically, we're going to be giving away any of their shelf stock pistons. So as long as you've got an engine that is supported by their shelf stock pistons, it's a pretty vast list, then this is going to be the perfect giveaway if you have been considering a rebuild of your engine. We're going to be coupling that set of forged pistons with a set of our engine building courses, so that you're going to know what to do once you get hold of those pistons. In particular, you'll be getting our engine building fundamentals, our practical engine building course, as well as our cam degreeing course. That giveaway has only just gone live today, so I think there's around about 20 odd days for that left to run. Hopefully I haven't thrown Scott under the bus, and he can drop a link into the chat that you can follow to get your name into the draw. And as usual, there's a couple of other tasks that you can do which will give you more entries into the draw, giving you more chances of winning. Alright, thanks for watching there, guys. Give me a few moments and we'll get started with today's webinar.
If you like that video, make sure you give it a thumbs up, and if you're not already a subscriber, make sure you're subscribed. We release a new video every week. And if you like free stuff, we've got a great deal for you. Click the link in the description to claim your free spot to our next live lesson.